take a look at our first problem. It says evaluate the radical expression. Write your answer as an integer, simplified fraction, or decimal rounded to decimal places. If the expression does not represent a real number, write not a real number. Okay, so we got the cube root of negative 64. First off, when you got an odd index and you got a negative number inside, you take the negative and put it on the outside of the radical. So we'll do that to begin with. Now 64 is 4 times 4 times 4. Now our index is the number in a slot here, and it tells us how many sets of whatever we're looking at. So we're looking for sets of 3 of something. So here's a set of 3 4s, so those 3 4s come out in front as a single 4. So our answer is negative 4. Now second problem, we have square root of negative 16. And the instructions say, use your knowledge of square roots and cube roots to determine whether the following is rational, irrational, or non-real. For purposes of what we're doing in this particular chapter, rational means you come up with a nice answer. The radical disappears. Irrational means it won't come out of the radical. And non-real is when you got a negative number inside of a radical with an even index. So this problem is non-real. We know that a negative inside of a square root actually gives us an imaginary. Okay, number 3, square root of 96. Well, if I do the prime factorization of 96, that's 2 times 48. 2's prime, so I circle it. 48 is 2 times 24. 2's prime, so I circle it. 24 is 2 times 12. 2's prime, so I circle it. 12 is 2 times 6. 2's prime, so I circle it. And 6 is 2 times 3. 2's prime, so I circle it. And 3's prime, so I circle it. So I got 1, 2, 3, 4, 5 2's. And 1, 3. 2, 4, 8, 16, 32, okay, 96. Now we're dealing with the square root, so we're looking for a pair of somethings. Well, here's a pair of 2's, that's going to come out in front as a single 2. And here's a pair of 2's, that's going to come out in front as a single 2. Now when they come out with multiplication in between them. And we're left with 2 times 3 inside. There's not a pair of anything there, so that just gives us 6. So our answer is 4 square root of 6. Okay, number 4. Cube root of 128. Well, 128, 2, 4, 8, 16, 32, 64, 128. Let me show the factorization tree. Okay, 2 times 64, 2's prime, so I circle it. 64 is 2 times 32, 2's prime, so I circle it. 32 is 2 times 16, 2's prime, so I circle it. 16 is 2 times 8, 2's prime, so I circle it. 8 is 2 times 4, 2's prime, so I circle it. And 4 is 2 times 2. And both those are prime, so I circle them. So we got 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Now, our index is 3, so we're looking for sets of 3 of whatever. Here's 3 2's, so those are going to come out in front as a single 2. And here's 3 2's. Those are also come out as a single 2. So we got 2 times 2, cube root, and we're left with 1, 2 inside. So that's going to give us 4 cube root of 2. Okay, number 5. Simplify the following expression. We got square root of 48 x to the 4th. Okay, well, let's do our prime factorization. 48, 2, 4, 8, 16. times 3, and 4 x's. If I did my factorization tree, I got 2 times 24, 2's prime size circlet. 24 is 2 times 12, 2's prime size circlet. 12 is 2 times 6, 2's prime size circlet. 6 is 2 times 3. 2's prime size circlet and 3's prime size circlet. Now we're dealing with the square roots. We're looking for a pair of somethings. Well, here's a pair of 2's. That's going to come out as a single 2. Here's another pair of 2's. That'll come out as another single 2. Here's a pair of x's. Those will come out as a single x. And here's another pair of x's. Those will come out as another single x. So we're going to have 2 times x times x, and we're left with a 3 inside. Well, 2 times 2 is 4, x times x is x squared, and then square root of 3. Okay, let's take a look at number 6. We get the cube root of 54x to the 8th. Now I'm going to use my shortcut on this instead of writing out 8 x's. Just so we refresh our memory on it. Though 8 x's wouldn't be horrible to write out. But imagine it's 80 instead of 8. Now 54 is 2 times 3 times 3 times 3 x to the 8th. Okay, if I look at the factorization tree on that, 54 is 2 times 27, 2's prime size circlet. 27 is 3 times 9, 3's prime size circlet. And 9 is 3 times 3. Both those are prime size circlet. Now to figure out how many x's is going to come out, we take our power, divide by our index, and the power is the power on x. The index is number in a slot right here. And this is old style division, so 8 divided by 3 is 2 with the remainder of 2. And this is how many come out, and this is how many stay in. Okay, our index is 3, so we're looking for a set of 3 of something. Here's 3 3's. They're going to come out as a single 3. And we said we're going to bring 2 x's out, so we'll have x squared. Cube root, we're left with a 2 inside, and we're also left with 2 x's inside. And that's our answer. And let's see, number 7. We've got the cube root of 32 x to the 12th, y to the 6th, okay, so for 32, we got 2, 4, 8, 16, 32, x to the 12th, y to the 6th. Okay, so let's figure out how many x's is going to come out. We take our power, which is 12, divide by our index, which is 3, and that gives us 4 with the remainder of 0. So that means we're going to have 4 x's come out. We'll have no x's remain inside the radical. For our y's, we'll take our power, which is 6, divide by our index, which is 3, gives us 2 with the remainder of 0. This is how many come out, and this is how many stay in. Well, our index is 3, so we're looking for a set of 3 of something. Here's 3 2's. They're going to come out as a single 2. We said we're going to have 4 x's come out, so we got x to the 4th. And we said we're going to have 2 y's come out, so we'll have y squared. Number-wise, we're left with a 2 and a 2 inside, so that's 4. And no x's and no y's. So that'd be our answer. Okay, number 8. We got 36 to the 1/2. Now, whenever you have a rational exponent, fractional power, if you got a 1 up on top, you just immediately want to rewrite it, assuming you have a number and you want to simplify it. You just immediately want to rewrite it into radical form. So this becomes this radical here. Now remember how that works. Whatever number's in your denominator, goes in your slot. That's your index. And whatever number's up on top is your power and goes right there. But 2 is simply the square root. So we've got square root of 36. And 36 is 6 times 6. And we're looking for pairs of something with a square root. So here's a pair of 6's. So they're going to come out in front as a single 6. And that's our answer. Let's see, number 9. We got 9 to the negative 1/2. First off, we never want negative exponents. And how we always get rid of negative exponents is we take an opposite of where it's at in a fraction. So I'll put this over 1. And then I'll take this 9 to the negative 1/2 and move it down below. When I do that, it becomes 1 over 9 to the positive 1/2. Whenever you move anything in a fraction, the sign of the exponent changes. And now it's like our previous problem. We got fractional power, and there's a 1 up on top in the numerator. So we're going to rewrite that in radical form. So that's going to become this radical right here. Again, the 2 goes in your slot. That's your index. The 1 up on top is your power, which is the square root of 9. And 9 is 3 times 3. So that gives us 1/3. So number 10, we got 27 over 8 to the 2/3 power. Now whenever you have a fractional power, rational exponents, and you got a number greater than 1 up on top, then you're going to go through our 3 steps for simplifying these. Our first step is to take the number up on top, the numerator, put it on the outside a set of parentheses, or brackets in this case. So we're going to have 27 over 8 to the 1/3 power, and I'll put the 2 on the outside of brackets. Now I'll put that back in the radical form, so this will be the cube root of 27 over 8, okay, which works out nice. Because 27 is 3 times 3 times 3, and 8 is 2 times 2 times 2. Remember, with an index of 3, I'm looking for a set of 3 of something. Right here I got 3 3/2. So those 3 3/2 comes out in front as a single 3/2. So we're going to have 3/2 to the 2nd power. So then we square the 3, which gives us 9, and square the 2, which gives us 4. So our answer is 9/4. Let me save that page. Eventually get there. Okay. Let's look at the next problem. Number 11. We got x squared to the negative 2 power. Well, remember, when you're raising any exponent to another exponent, you multiply the exponents together. So 2 times negative 2 gives us negative 4. Now, we never want negative exponents, so I'm going to put this over 1. And how you get rid of a negative exponents is you take the part of the negative exponent opposite where it's at in a fraction. So I'll take this x and negative 4 down below. And I'm going to get 1 over x to the positive 4. And that's our answer. Okay, number 12. We got a to the 1/2 times a to the 4/5. Now, whenever you have a to a power times a to a power, you're going to add the exponents. So we're going to have a to the 1/2 plus 4/5. Well, adding fractions works out better if they have a common denominator. And 10 would be our common denominator. So I'm going to rewrite each fraction with that new denominator. Now my first fraction, I multiply the bottom part by 5, so I have to multiply the top part by 5. On my second fraction, I multiply the bottom part by 2, so I multiply the top part by 2. And at that point, once I have the same denominator, I can add together the top parts. 5 plus 8 is 13. So we're going to have a to the 13/10 power. Okay, 13. We got 3y to the 3/5 raised to the second power. Now, if everything inside of your parentheses is either multiplication or division, and you're raising the parentheses to a power, then you can take everything inside the parentheses that power. So we're going to take the 3 to the second power and the y to the 3/5 to the second power. So we're going to have 3 to the second power and y to the 3/5 to the second power. Now 3 squared is 9. And here, when you raise one exponent to another exponent, you multiply the exponents together. 3/5 times 2, you multiply 3 times 2, so that gives us y to the 6/5. And that's our answer. Number 14. We've got -3 square root of 50 plus 4 square root of 6. First off, you always simplify your radicals before you do anything else. So let's start there. 50 is 2 times 5 times 5. And 6 is the square root of 6 gives us square root of 2 times 3, which doesn't go anywhere, so I don't need to break it down. Now remember, with square roots, we're looking for a pair of somethings. Here's a pair of 5, so a pair of 5 is going to come out in front. And that gives us -3 times 5 square root of 2 plus 4 square root of 6. -3 times 5 gives us -15 square root of 2 plus 4 square root of 6. Now since they have different radicals, I can't combine those together, and that would be your answer. Okay, number 15. We got 3 square root of 27 plus 6 square root of 3 minus 9 square root of 5. Again, you always want to simplify your radicals anywhere you can in a math problem. So let's do that first. 27 is 3 times 3 times 3. Now we can't do anything with the 3 in the second square root, and I can't do anything with the 5 in the third square root, so I'll leave those alone. Now remember, we're looking for pairs of something. So here's a pair of 3's. They're going to come out in front as a single 3. So we've got 3 times 3 square root of 3 plus 6 square root of 3 minus 9 square root of 5. 3 times 3 is 9, so we've got 9 square root of 3 plus 6 square root of 3 minus 9 square root of 5. And the first two, since they both have a square root of 3, I can combine those together. So I add the numbers in front of them. 9 plus 6 gives us 15 square root of 3 minus 9 square root of 5. And that's our answer. Number 16. We got -3 square root of 25x minus 8 square root of x minus 4 cube root of x. First off, we'll simplify that first radical. square root of 25x. 25 is 5 times 5 with an x, minus 8 square root of x, minus 4 cube root of x. Now remember, we're looking for pairs of something. So in this first radical, we have a pair of 5, so I can come out of the square root as a single 5. So we've got negative 3 times 5 square root of x, minus 8 square root of x, minus 4 cube root of x. Which gives us negative 15 square root of x, minus 8 square root of x, minus 4 cube root of x. Now since these are both x's, then I'll add or subtract the numbers in front. Negative 15, negative 8 is negative 23. Yeah, negative 23 square root of x minus 4 cube root of x. Now we can't combine those two together because one of them is a square root and one of them is a cube root. They have to have the same index for you to be able to combine them together. Okay, number 17. Let me grab a drink here. Okay. We have 2 square root of 150 plus 5 square root of 96 minus 6 square root of 54. Well, first off, let's simplify the radicals as much as we can. 150 is 2 times 75. 75 is 3 times 25, and then 5 times 5. So we got 6, 30, 150. Plus 5, 96 is 2 times 48. 48 is 2 times 24. 24 is 2, 4, 8, 3. 2, 4, 8, 16, 32, 96. Minus 6 in square root of 54. That's 2 times 27, and 27 is 3 threes. Okay, so we're looking for pairs of something. Here's a pair of 5s. That's going to come out in front as a single 5. Here's a pair of 2s. That'll come out. Here's a pair of 2s. That'll come out. Over here, we got a pair of 3s. That'll come out. So we got 2 times 5, and then we're left with 2 times 3 inside, which is 6, plus 5 times, I bring one pair of 2's out and bring another pair of 2's out, and then we're left with 2 times 3 inside, which is 6, minus 6, and we bring that pair of 3's out as a single 3, and that leaves us 2 times 3 inside, which is 6. So that gives us 10 square root of 6 plus 20 square root of 6 minus 18 square root of 6. Which all three of these have the square root of 6, so I can add or subtract the numbers that are in front. 10 plus 20 is 30, minus 18 gives us 12 square root of 6. And that's our answer. Okay, number 18. We got 6 square root of 9y plus 3 square root of y minus 5 square root of 5. Again, you should always simplify your radicals, and the only simplifying I can do is the 9. 9 is 3 times 3. All the rest of these just carry down. Now we're looking for a pair of somethings. Here's a pair of 3s, so a pair of 3s is going to come out in front as a single 3. So we've got 6 times 3 square root of y plus 3 square root of y minus 5 square root of 5. Well, 6 times 3 is 18, so we've got 18 square root of y plus 3 square root of y minus 5 square root of 5. 18 plus 3 is 21 square root of y minus 5 square root of 5. And assuming I wrote it down right, and those really are square root of y and square root of 5s. Let's see if I did. y, 5. Okay, I guess they are. Then you can't combine those together, and that would be our answer. You can only combine them together when radicals are the same. Okay, 19. We got square root of 10 times square root of 2. Well, we're multiplying these together, and they have the same index, so we'll just multiply them together, put them underneath a single square root. So I got 10 times 2. You don't actually multiply them together because you're hoping that something will simplify. 10 I can rewrite as 5 times 2. And that'll bring down that 2. Now once I do that, I see I have a pair of 2's. So a pair of 2's comes out in front as a single 2. And our answer is 2 square root of 5. Number 20. We got square root of 6 minus 6. And square root of 6 minus 4. Well, we're going to multiply these together. FOIL, if you like that technique. So we'll take square root of 6 here, times square root of 6 over here, and times the negative 4. And then we'll take the negative 6 times square root of 6, and times the negative 4. Okay, so that gives us square root of 6 times square root of 6, square root of 6 times negative 4, negative 6 times square root of 6, and negative 6 times negative 4. Now when you're dealing with square roots and they're the same, square root of 6 times square root of 6, that gives you 6. Minus 4 square root of 6, minus 6 square root of 6, and negative 6 negative 4 gives us 24. We'll combine together numbers. 6 plus 24 is 30. And these radicals are the same, so I'll add numbers in front. Negative 4, negative 6 gives us negative 10 square root of 6. And that's our answer. Okay, number 21. We got square root of 5 minus square root of 7 times square root of 5 minus square root of 7. Well, same thing as last problem we just looked at. We're going to FOIL it. So take square root of 5 here times square root of 5 over here, and times negative square root of 7. And I'll take negative square root of 7 times square root of 5 and times negative square root of 7. Okay, so we got square root of 5 times square root of 5. We got square root of 5 times negative square root of 7. We got negative square root of 7 times times square root of 5. And we got negative square root of 7 times negative square root of 7. Well, when the square roots are the same, square root of 5 times square root of 5, that gives you 5. Minus square root of 5 times 7. Minus square root of 7 times 5. And negative times negative is positive, and square root of 7 times square root of 7 gives us 7. Well, 5 plus 7 is 12. And these radicals are the same, and they both give us 35. So I got negative 1, negative 1, which gives us negative 2 square root of 35 when I combine those together. Okay, number 22. We've got negative square root of 3 times square root of 5 plus square root of 6. Now this is a distributive property, so we're going to take negative square root of 3 times square root of 5 and times square root of 6. So we've got negative square root of 3 times square root of 5 and negative square root of 3 times square root of 6. Now 3 and 5 are both prime, so I can't do any simplifying there. So this is going to be a negative square root of 3 times 5. I'll go ahead and multiply those together in the next step. But this next one we're going to see we can do some simplifying, because we got 3 times 6, and 6 looks like it can break down. Okay, so that gives us 15 minus square root of 3 times 2. Prime factorization is 6. And we got a pair of somethings here. Here's a pair of 3s, so that's going to come out in front as a single 3. So we're going to have negative square root of 15 minus 3 square root of 2. And that's our answer. Now number 23. We got square root of 21 over square root of 3. Now this problem looks like it would do me some good to put into as a single fraction, because 21 divided by 3 would give us 7. So I'm going to merge this into a single fraction. I have square root of 21 over 3, which 21 divided by 3 is 7, and our answer is square root of 7. The problem, of course, is we can't have a radical in the denominator. That was our main issue from the first. So we'll go ahead and save that. And start a new page. Okay, so 24. We have square root of 55 over square root of 15. Well, this looks like if I can merge them together into a single radical, it'll simplify a little bit. So I'll give me a square root of 55 over 15. And those are both divisible by 5. So that gives us square root of 11 over 3. And now I must split it back apart. So I got square root of 11 over square root of 3. Now the problem with this is that we can't have a radical in the denominator. So I'm going to multiply the top and bottom by the square root of 3. So that gives us square root of 33 over square root of 3 times square root of 3 gives us 3. And that would be our answer. Now 25. We've got the cube root of 24 over the cube root of 15. Well, it looks like I could merge these together temporarily into a single fraction as a start, because they're both divisible by 3. So we'll have the cube root of 24 over 15. And like we said, both of those are divisible by 3. 24 divided by 3 is 8. 15 divided by 3 is 5. Now we can't have a fraction inside of radical, so I'll split it back apart. I'll put a cube root around the top and cube root around the bottom. Now up on top, 8 looks like I can simplify it. 8 is 2 times 2 times 2. Bottom I can't do anything with temporarily. I'll come back to it though. Now up on top, our index is 3, so we're looking for sets of 3 of something. Here's 3 2's, so those 3 2's are going to come out in front as a single 2. So we got 2 over the cube root of 5. Now we can't have the radical in the denominator. So how we get rid of that is, since our index is 3, that means we need 3 of whatever. We have 1 5, so I'm going to put down 2 more 5's. And then we'll have 3 5's. And whatever you multiply by the bottom, you have to multiply by the top. So this is going to be 2 cube root. 5 times 5 is 25. And down below, our index is 3, and we have 3 5's, so that gives us a single 5. And that'd be our answer. Number 26. We got x over the square root of 6y. Well, can't have the radical down denominator. So this is a square root, so we're going to multiply the top and bottom by the square root of 6y. Whenever you're dealing with square roots, it's always just whatever this radical is. Well, x times square root of 6y gives us x square root of 6y. And square root of 6y times square root of 6y gives us 6y. And that's our answer. Okay, 27. negative 5 equals square root of 1 minus 3t. And let me put an x there instead of a t. I don't do x's, t's very well. Well, this is a radical equation. So our first step says to get a radical by itself. Well, this radical is by itself. There's nothing in front of it. There's nothing after it. We just got square root. Our second step says to raise both sides to a power equal to the index. Well, this is a square root, so your index is 2. So we're going to square both sides. So we got negative 5 squared is equal to the square root of 1 minus 3x squared. Now negative 5 squared is 25. And when your index matches the power you're raising to, they cancel each other away. So that gives us 1 minus 3x. Now we want to solve for x. So I'm going to take this negative 3x and move it to the left side. And I'll take that 25 and move it to the right side. So we got 3x is equal to 1 minus 25. 1 minus 25 is negative 24. Divide both sides by 3. And you get x is equal to negative 8. Maybe. Remember, we have to check your answers. If we put negative 8 back up here, and for x, I got negative 3 times negative 8, which is positive 24. 1 plus 24 is 25, and square root of 25 is 5. So I get negative 5 is equal to positive 5, which is not check. So that one fails. Since there is no answers, then our answer is no solution. (28). We got square root of 4x plus 5 equals square root of x plus 8. Okay, well, our steps for solving radical equation. First step is to get a radical by itself. That's done. Our second step is to raise both sides to a power equal to the index. These are square roots, so we'll square both sides. So we've got square root of 4x plus 5 squared is equal square root of x plus 8 squared. Now whenever your index matches a power, they cancel each other away. So that gives us 4x plus 5. And this one gives us x plus 8. Now we're solving for x. So I'll take this x, move it to the left side, take this 5 and move it over. You take anything across your equals, your sign changes. So we've got 4x minus x is equal to 8 minus 5. 4x minus x is 3x, 8 minus 5 is 3. Last step, divide both sides by the number in front of your x, which is a 3. And we end up with x equals 1, maybe. We have to check it. If I put 1 back up in my original problem, 4 times 1 is 4, plus 5 is 9, square root of 9 is 3. If I put 1 over here, 1 plus 8 is 9, square root of 9 is 3. So that one checks. Okay, 29. We've got square root of 12x plus 13 equals x plus 4. Okay, our steps for solving a radical equation. First step is to get a radical by itself. Well, this radical is by itself. Nothing from it, nothing after it. Step 2, raise both sides to a power equal to the index. Well, this is a square root, so we'll square both sides. So we've got square root of 12x plus 13 squared is equal to x plus 4 squared. Now again, when your index matches the power you're raising to, they cancel each other away. So we've got 12x plus 13. Over on the right side, x plus 4 squared we'll write as x plus 4 times x plus 4. We can't just square the x and can't square the 4 because of the plus. You have to rewrite it this way. So we've got 12x plus 13. X times x is x squared. X times 4 is 4x. 4 times x is 4x. And 4 times 4 is 16. So then we've got 12x plus 13 equals x squared. 4x plus 4x is 8x plus 16. Now this is a quadratic. We have an x squared. So we want to get everything over one side, 0 on the other, and then factor. So I'll take 13, move it over, and I'll take 12x and move it over. Remember, when you move anything across or equals, your sign changes. So we're going to have x squared plus 8x minus 12x plus 16 minus 13. 8x minus 12x is negative 4x. 16 minus 13 is 3. Now this is going to factor using the PSD. So this factors as x minus 1 times x minus 3 Now, zero factor property says you get 0 on one side, you factor the other side, you set each factor equal to 0. So I'll set x minus 1 equal to 0 and x minus 3 equal to 0. And that gives us x equals 1 and x is equal to 3. Maybe. Remember, we have to check our answers. If I put 1 back up here, 12 times 1 is 12, plus 13 is 25, square root of 25 is 5. If I put 1 over here, 1 plus 4 is 5. So I get 5 equals 5, so that checks. If I put 3 back up there, 12 times 3 is 36, plus 13 is 49, square root of 49 is 7. If I put 3 over here, 3 plus 4 is 7, so you get 7 equals 7. So that checks. Okay, number 30. We got 2 equals square root of negative 3x plus 7. I'll continue using x's, plus 1. Okay, step 1 is to get a radical by itself. Well, this radical isn't by itself. We have to take that 1 and move it over. Again, you take anything across or equals, your sign changes. So it becomes 2 minus 1 is equal to square root of negative 3x plus 7. 2 minus 1 is 1 equals square root of negative 3x plus 7. Step 2 of solving radical equations is to raise both sides to a power equal to the index. So we'll square both sides. So we've got 1 squared equals square root of negative 3x plus 7 squared. So 1 squared is 1. And remember, when your index matches the power you're raising to, they cancel each other away. So we've got negative 3x plus 7. Now we want to get everything with an x on one side, numbers on the other. So I'll take negative 3x over the left side and take the 1 over the right side. So we got 3x is equal to 7 minus 1. 3x is equal to 6. Or x is equal to 2. Maybe. We have to check it. If I put 2 back up here, negative 3 times 2 is negative 6, plus 7 is 1. Square root of 1 is 1. 1 plus 1 does give you 2. So that one checks. I think that's the last. Yes, it is.